No idea what it is.
Okay.
Like why we are not.
Okay, no problem. So
basically I have not got the question.
so the question is very simple. First, you have you look at this left unit cell. Okay, unit cell. This is FCC unit cell, isn't it? There are atoms at the face center, isn't it? And you have atoms at the corners also. Yeah, this is here gray atoms. Gray atoms at the corners, orange atoms at the face centers, isn't it? Now, this you are actually repeating. You are actually translating this in x-axis and y-axis. Right? Z-axis you have not gone. Fine. So x-axis, suppose this is the x-axis, this is the y-axis. So x-axis you are translating it by 1 unit. So you are getting another unit cell, and y-axis you are getting another unit cell. And similarly, based on that, you have to have another unit cell so that it comes to around 4 face-centered cubic unit cells. But now, when you are doing it, I'm not saying that I'm doing the wrong thing. Why am I saying that I'm not doing the wrong thing? Why am I not incorrect in this? What is something that is there in a crystal that makes me right in this? No, otherwise I could have easily claimed that
basically the face center atoms are shared equally.
Okay.
For that reason, if the share is and all are uniform crystal structure, so by virtue of that, we can say that you are not wrong.
Why? I mean, shared equal is fine. Okay. So what does it lead to? There is something called what? Translational symmetry. Translational symmetry. So now, in a crystal, what happens? You have an atom. See, suppose you have an atom here. Look at the cursor. You have an atom here. You have another atom here. Third atom should be here, or third atom should be here. If the third atom is here, can you call it a crystal? Can you call it a crystalline structure?
No.
No. Why?
It would have, the crystalline structure would have regular translation.
Yes, so that's called translational symmetry, isn't it?
Yes.
So that's called translational symmetry. So because of translational symmetry, so for your level, till now, I think the best thing to understand is the translational symmetry. I mean, I am not dragging into that. Again, you will be confused, not be able to answer. I understand the question. So, so let's keep it this way. So that's what. So that's why I'm not wrong, because I can translate it in XY. Even I can translate that also. Z-axis also I can translate it. There is no problem. I can do it. But now we don't need to translate it because we are already solving our purpose. No? We are already solving our the octahedral structure. The octahedral structure we are still able to obtain from this. How do we get an octahedron now? So now you have 2 atoms which are the corner atoms, and they are being shared by the first and the second unit cell, FCC unit cell. You're getting the point, right? So first and second. So this is the first unit cell, this is the second unit cell. These are the 2 corner atoms which are being shared, isn't it? So they are being shared. And now you have these 2 as the face center. So pehla wala jo face center hai, this is the face center, and this is again the face center. Because see, that's the reason I had to draw 4 things, 4 unit cells. Now, you also have the 2 atoms which are present at the first and the second phase centers, right? I mean, of this first unit cell and second unit cell, these are the 2 phase centers. So based on that, you can get what? This thing, you will extract this out. You have this thing, you have this octahedron, isn't it? Now, you got this, right? Are you able to understand? Follow me, or yes or no? I mean, if you're not,
yes,
please ask.
Yes, sir. Yes, sir.
Okay.
Yes.
Okay. Okay. Fine. So now let's proceed. Okay. Now suppose I will tell you one thing. So now suppose you have an atom here. Now I will give an example. Suppose you have an atom here, you have an atom here. This cheese ko I am showing in 2D. Okay. So actually, do you know this atom, when the atoms are positioned, see, atoms won't, there is no line. There is no line between atoms, of course. But, for simple, what to say, for simple understanding, or for the simplicity in the understanding, what do we actually have to do is that we have to use this, we have to use this thing, like, we have to use a simple hard sphere model. We call it a hard sphere model, or a matchstick model also sometimes we call it. So this is basically called a matchstick model. No, you can take different matchsticks. You can have different balls which are present in between the match, not balls, rather they're a small, what do we call it? Okay, small balls which are present with the matchsticks. We can stack them together. So, but when the atoms are there, there is no thing, nothing is like this. Atom will be like this, and the other atom will be like this. But actually, the space between the atom is actually what we are interested to find out. But we are not exactly interested to look into the real. We can look into the real structure, but for the simplicity in understanding, we need this position. We need this blank space So these two gray atoms, these are two gray atoms. Okay, suppose these are two gray atoms and this is the space. Okay, and this size of the void, is going to tell me what is the size of the octahedral void, right? Because this is where you can, so this is an octahedron that you can imagine surrounding, or the 6 sides of the octahedron, which are actually going to, the 8 sides of the octahedron, which are actually going to surround this thing, this central thing, no, the central thing. Now let us do some mathematics on this. It's a simple thing. There are two atoms, isn't it? So the two atoms are actually having a radius of r. Each atom, this atom has radius of r. This atom also has radius of r. So similarly, now let us extract this. So what is this? This is nothing but x. This is radius of the largest atom which may be fitted within the void. Because see, void, how do we think? See, in a void, how do we think? We can only think it in this way, that the size of a void should be equal to the size of something, and the something should be an atom, of course, because we're talking in atomic level. The size of the atom which can be fitted within the void, isn't it? So when you are fitting the atom within the void, so in that case, so x is the radius of the void, and r is the what? So this is the radius, r is the radius. X is the radius. So the total diameter, or the diameter of this entire space, of this entire line, actually. So rather this is 2x. So similarly, r is the radius of this. R is again the radius of this. So it will be what? 2x plus 2r, isn't it? So and what is that equal to? That is equal to I mean, I don't know what. I mean, is it come for that? So that is equal to what? That is equal to 2r plus 2x, which is equal to a, isn't it? So a is what? A is the lattice parameter. Lattice parameter you are aware of, right? You know what is lattice parameter, right?
Yes, sir.
Sure. So if you don't know what is lattice parameter, you can ask me now also, no problem. I can tell you what is lattice parameter. But I think in class 11, 12th, I think they might have taught this,
We know lattice parameter.
Fine. So this 2x. So this is 2x. So if this radius is x, so this is 2x, x plus x is 2x, this is r, this is r. So r plus x plus r plus x. So this is called 2r plus 2x. So this is equal to a. And that and now, okay, now the catch is there. The catch is, see, in FCC, what actually happens? What is the relation between the, between A, between A and R? A is what? Lattice parameter, and what is the atomic radius? Atomic radius is, the total. The atomic radius R is actually equal to what? Root 2 by 4A, right? Or how do we now say it? Or we can also say it as A is equal to 2 root 2R. That is in FCC, no? For BCC, do you know what is the relationship? BCC, any idea?
Root 3a by
Root 3a by
4.
4. So that's what. So root 3a by 4. So that's a simple thing, no? So when you talk of this, now I'm talking of FCC. That's what I didn't go into BCC. Again, the BCC, so thinking will be a bit harder. So okay, so root 2a is equal to 4r. Now you have to just put it in this equation. So what do you get ultimately? X by r is equal to root 2 minus 1. It's 0.414. So this is something. So what is x? X is nothing but the radius of the void, and r is nothing but the atomic radius. So the ratio of this will actually give you what? 0.414, isn't it? Similarly, now, so this is something that you can easily, that after explanation, I think you can easily understand. If you don't understand, please ask me now, right now. How many of you didn't understand this calculation? All have understood? Yes or no?
yes.
Okay. Anyone who has not understood? Okay, I don't think they're not responding. I don't know what to. But okay, if you have doubt, you can write it. Okay, you can write it in the Google Classroom that you have a doubt. Then I can again explain it. But anyways, I have the recording of this also. This being recorded. So fine. So now I need to show you one important thing, that when you are having an octahedral void, for example, you are having an octahedral void. So in a octahedral void, you are I'm talking of what are the positions? What are the positions of this void? So now looking at this, what are the positions? So these are these positions, right? So octahedral void position. So this is actually this particular position. So you are having a void here, right? You are having a void here. Similarly, you can also have a void here, and similarly, you can have a void here. You can have a void here, and so there are different positions, isn't it? So when you are having a void at the at this position between the two atoms. So what do you call it? It is 0, 0, half, isn't it? Or it's a kind of it's if you consider this to be the x-axis, then it should be half 0, 0, isn't it? Similarly, this should also be 0, half 0, because this is 0, 0, 0 translation along the x-axis. So this is the x-axis, this is the y-axis, and the upper wala, the top axis is the z-axis, right? Now in that case, so if you are having a void here, oh sorry, yeah. So if you are having a void here, what is the indices of that void? What is the indices? I'm talking about void. Anyone? Both of them. What is the indices of the void? If you are having a void here, what should be the indices of the void? Here, you are clear with the question, right? If you don't understand, please ask me now. I don't know. If I have a void here, I'm asking that if you are having a void here, what should be the indices of the void? In the cursor, mouse position, you look at the cursor position. You're having a void here. Okay, this I said what? Half 0, 0, right? Half, this is half, right? This is total 1, so it's the beach mein. So this is half 0, 0. 0 is what? 0 is along the y, there is 0, and similarly z is along the 0. I mean along the z it is 0. So similarly, if you are having a void here, then what should be?
0, half 0.
0, half 0. So it's a simple. So similarly, you are having a void here, then it should be what? 0, 0, half, isn't it? So kind of. So in that case, you should actually have not. I mean, in that case, you are so totally. You can calculate this yourself. Actually, I mean, if otherwise you have to write it in the copy and do it. But okay, you can. This I can give you as an assignment to do. And a simple assignment. No need to. There is nothing. No evaluation. Just for your understanding only you can do. So if it is half 0, 0, it's I'm talking of the family. So when I'm talking of the family, I'm denoting it by a curly bracket, isn't it? So that's why. Otherwise, if it is half 0, 0, if I am not using a curly bracket and I'm using this simple bracket, okay, simple bracket, like the second bracket. So that will actually say that you only have a void at this position, and rather you won't have a void at these positions. But then that is wrong, because you will definitely have a void here, here, as well as here. So definitely you will have total three voids, 3 octahedral voids in this location. Now there is another location where you can have a void. Can you? Okay, can you identify which other location you can have a void? I think this Pranav was talking about this the other void, the other kind of a void. He was talking BCC. Let's talk
Body center.
Body centered. So in body centered position, there is another void. There is, even you can think of it as an octahedral void, right? So half means what? Kya hota hai? Body center mein hoga. Yahan pe you cannot show it. There is no atom at the body center here, right? See, again you can think of an octahedron here also, no? In one unit cell also you can think of a void. So first I made it a bit difficult for you, because so first I told you to make 4 unit cells. And these 4 unit cells, you can stack them together and you have nothing wrong, because you have a translation symmetry. And you have atoms which are placed at different distances, of course, because you can imagine, this is all imagination. So this is crystallography. So you have to think of a void here. Similarly, when you have a simple one FCC unit cell, you don't have to think of the others. Simple 1 unit cell, you can talk of a void here also. So that is, you if you join all these parts, okay, so you get a what? You get an octahedron, right? You don't have to think of this at all. So all these 3 other unit cells, these things are all gone. Now you just think of one. Okay, so you join this and this. Okay, look at the cursor position. Join from here to here. So all these you join. So what you will get? You will ultimately get a void, right? You will get a what to say? You will get an octahedral void. So that is 1. Half void is 1. So that is called total kitna hoga? Half is 1 in 1 unit cell. Similarly, half 0, 0 is 3. So there are total 1 plus 3 is equal to 4. So right. So there are 4 octahedral voids per unit cell in FCC. Right? You are clear with this?
Yes.
I have a question.
Yes, please ask. Go ahead.
Basically, you have signified that using the third bracket means to signify the all 3s.
Location.
Half 0, 0,
I mean, yes. Family.
Yes. But but in case of body centered one, the half comma half comma one half, if I use first bracket, then it will signify the same thing.
Yeah, definitely. Now I will tell you. So this is a very interesting thing. So the interesting thing is that half, you can use a curly bracket. I mean, sorry, you can use a second bracket. I mean, simple, normal bracket. So in that case, it is correct only. In this case, it is correct. Since there is only one. But now I will tell you. Now suppose you had you had some other location. I mean, it is not half, and you are having it as around half 1/4, because you see all these things in a body centered body centered cubic structure. That's why I didn't want to start with the body centered cubic structure. It will be a bit hard for you to visualize. So that's what. So if you have a half 1/4 or something like that, okay, or half sometimes 1/4, 3/4, something crazy comes up, 1/2 and something. So you will definitely not have it as one. No, you will definitely have it as more than one. If it is more than one, then you can use this. Then using this gives you a safe. Then you are safe, because if you use this curly bracket now here, is you are using a curly bracket, it is not wrong. Rather to say, if you are having one void, and even if you are using curly bracket, it's not wrong, because curly bracket means it's a family. Now the family there can be one in a family, there can be thousands in a family. It doesn't matter. But now if you are using a second bracket for 2, 3, 4, 5, it is wrong. So the reverse wala thing is wrong. I mean, if you are using a second bracket for half 0, 0, it is wrong. It is not correct, right? But if you are using a curly bracket for even one, I mean, even a location, I mean, even a void, which is only one, I mean, only one void is there, then it is not wrong. I mean, curly is, I mean, rather to say, I will put it this way: curly bracket is in crystallography is a superset. In mathematical way, it's a superset of the second bracket, right? So, am I clear with the answer? Need more explanation.
No, basically, yes, basically I understand the fact, but I have a technical miss. It would be a technical issue, because without using the curly bracket, using the first bracket, means simple bracket, to signify only one, will it be a technical issue?
No, it's not. That's what I'm saying. See, it's not at all a technical issue. Rather, I'm saying that if you are using a curly bracket, okay, you are using a curly bracket, and you have one, it is not wrong at all. Why? Curly bracket is going to signify that it is a family. Now, in that family, there can be one also. I mean, in that family, there can be one member also, right? It's like a simple, normal. You think of human lines of the same thing. In a family, there can be one. In a family, there can be two also. Now, when you are having two, when you are having one, you use a curly bracket. It's universal. It's a superset. It's not wrong. But now, if you are using a second bracket and you are, your total number of voids is 3 or 4 or something, so then it is wrong, because it is that second bracket is only going to suffice for only one. What to say? Only one amount, or only one quantity, rather to say. So you cannot have 2, 3, 4, 5, 6. You cannot never use. You can never use a second bracket. I mean, a second bracket for that. You can only have a curly bracket for that, isn't it? So crystallography, curly bracket is something which is universal. I mean, if you use curly bracket for one, it's not wrong, not at all wrong. I don't know. I mean, this is the conventional crystallography. It is correct only. There's no problem. Yes. Am I clear with the answer now?
Yes. Thank you.
Okay. Anyone has any other doubt? Please ask now. Right away. So you guys understood this? I don't know. Yes. Okay, fine. Okay, so if you guys have understood this, now let's proceed a bit ahead. No, when we are already a bit late. This is running a bit. Okay, tetrahedral void. Any idea what is a tetrahedral void now? ये structure देख के तुम confuse मत हो जाना. What is a tetrahedral void? What is a tetrahedral void? What is a tetrahedral void? Tetra. I'm using the word tetra.
A void surrounded by 4 atoms.
Right. Simple. So you have a FCC. Okay. Now let me not give you the indices. Can you? So looking at this diagram, can you tell me what should be the indices of this tetrahedral void? Indices of tetrahedral void. Any idea? See, just consider this thing. Just consider this the cursor that I'm showing you. This position. Okay, this position has the 0, 0, 0 position. So Then which are the positions of the tetrahedral void. And this is a bit tricky, I know, but let's. So brain teaser, no? Brain teaser will make you keep you alive in the class, otherwise you'll sleep. Anyone? Yeah, I think you guys are having a hard time with this. Okay, now let's proceed ahead. I think this is quite hard for you to understand, isn't it? So you guys are finding it difficult? Yes or no? Difficult? I have asked this word difficult. Are you able to do it? Because anyways, I'll be solving it, but okay, but let's see. No, I'm not sure I'm able to think about it. So people are getting void. Their mind is getting void when you're looking at the word void, tetrahedral, octahedral void. People understand their brain has started becoming void. So let's see one thing. So I don't know, but let's do one thing. Okay, now let's do it. Okay, so these are the positions. This is not at all difficult and it's too easy. So, okay, so the void position, this position, okay, point T. So this red position I was talking about, okay. So this red position is a void position. So this position is actually hard for you to, guess this position, but it's what to do. I mean, okay, so it's nothing but this position is actually 1/4. I mean, 1/4 away from each vertex of the cube. So each vertex of the cube means what? This vertex, this vertex. I mean, of course, the other vertex, it should be 3/4, but okay, the 2. So 1/4. Okay, the interesting thing is that I will now ask you one thing. So this 1/4 away from each vertex of the cube along the body diagonal. What is the body diagonal? Body diagonal is this, no? This atom to this atom. Like atom A to, I have not marked this or I have not labeled this, but this is a body diagonal, right? Phase diagonal is a different thing. Body diagonal is a different thing. So along the body diagonal, this atom has to have a distance of 1/4 from this. I mean, this, if you see the cursor very carefully, and this is the other position A, the position A is this one, no? The position A. So 1/4, 1/4. And then from here to here, so this must be lying along this diagonal, and this must be having a, a distance of 1/4, and this also should have a distance of equal to 1/4 from here, isn't it? So, so now what do you think? Now, can you, so this is the position, right? I mean, I have made a mistake here. I mean, it is not actually correct. So because when I made this 1/4, 1/4, 1/4, this should actually be in a curly bracket. I made a small mistake here, and I admit that there should be a curly bracket, because I myself have said now that there should not be. Why I have made this, I don't know, but please, I'm sorry for this, but there should be a curly bracket, 1/4, 1/4, 1/4. Now the question is, now if a void is here, isn't it? The void is here. It is at a distance of 1/4 from here, 1/4 from here. So from here, this position and the other position, how much distance it will be? Or rather to say, not this way, rather to make it a bit simple. An atom is at 1/4 from here, 1/4 from here. How much distance will it be from here and here? Total is, says if the total is 1, then how much from the bottom 2? This and this. Anyone, you can speak up fast.
So 3/4.
Yeah, 3/4. But now the thing is, why do we not write 3/4 in any crystallography? Why do we not write 3/4? We are writing 1/4 only, the 1/4 family, right? We are writing 1/4 family. Why do we not write 3/4?
Because when
Sir,
we,
actually-
if there is a common factor of 3, then we could divide it to make it 1/4.
Okay,
In
that's common
terms of
factor. Okay, that
simple-
is, yeah. Okay, good. So that is what? So that is mathematical way. Okay, another some other answer. Correct. You are not wrong. You are right. Only.
Sir, here, sir, what is the origin point?
origin point, suppose I give you this thing. This is the origin. Suppose do you look at
This.
okay.
Yes, sir. Then, sir, we can write the 3/4, sir. Or
So fine, 3/4 you can write, but can you write or can you not write? That's what I'm saying.
sir, we write if the voyage distance from the origin is 3/4.
Okay. And
But sir, here we make the origin at the sir A.
okay,
the
fine.
point.
Fine. If I make it at the A, then what will happen?
Then sir, the distance from the origin of the void is 1/4. Then,
okay, very good. So now like whatever you have said, now think that if it is 1/4, 3/4, what is the distance between 1/4 and 3/4? What is the difference? Half, no? Half is the distance, right? Now 1/4 plus half is 3/4. So now, so what is half here? I mean, it's a very simple. Again, I think of translational symmetry. I mean, what will happen? I mean, that's what translational symmetry is important. Everywhere it is important. So, an atom which is sitting at 1/4, it is considered to be. I mean, it can be considered in a cubic unit cell. In any cubic unit cell, not only FCC, it can be BCC also. Any cubic unit cell, it can be simple cubic also, but simple cubic definitely you don't have all these atomic positions. Okay. In FCC and BCC, if you are having any atom which is sitting at 1/4, it can be considered to be equivalent to what? 3/4, right? Isn't it? So
yes, sir.
why? Because the atom can, that's what I told you. An atom can travel 1/4. Then 2 times 1/4 easily it can travel, because see, it's a multiple, na? It's a multiple. 1/4 ka multiple, 1/2 is a multiple of 1/4, because 1/2 is equal to 2 times of 1/4. So 1/4. उसके बाद 2 बार गया, और 2 बार जाने के बाद, because that is again what I will call it a translational unit. That is called a translational unit because that is equivalent, ना? क्योंकि एक position से there are suppose A and B. Now I give you one thing, not A and B. I will give you a simple thing. Now this position and this position, and atom is 1/4 from here and here. Now similarly, from the other positions, okay, from the other positions, like suppose, if you are considering along the body diagonal, I'm not considering along the, along this cube edges, I'm considering along the body diagonal. So these two positions, it will be what? It will be 3/4, right? This position, but now there's a but. The but is, when this thing is here, now suppose I'm considering this, so all these white positions you are seeing, white positions, all these white positions are actually the the tetrahedral void sites. Now suppose this position I give you, okay? Well, this position is actually at a distance of 1/4 from both these things, isn't it? But it is actually at a distance of 3/4 from both these. So both these positions are equivalent, isn't it? So these positions are equivalent. So all these 8 positions are equivalent. 1, 2, 3, 4, 5, 6, 7, 8. All these positions are equivalent. So as all these 8 positions are equivalent, so you are having what? 8 void split cell, 8 tetrahedral void positions. So okay, just ask me now. I think there will be a lot of doubt here. Please ask me now, one by one. You can ask them these questions. I don't think you might have understood it completely in the first round, because it is a bit hard to visualize. Definitely. You can ask, no problem, you can ask me. If you have a doubt, or you have understood everything.
So you are a bit fast.
Oh, I'm a bit fast. Okay, I'm sorry for that. Okay, I'm sorry. I'll be speaking slowly from now onwards. I'm sorry for that. Yeah, I'll do that. Okay, so did you understand or not? I mean, if you don't understand, please ask me. What did you not understand? If you don't understand from the starting also, I will explain it now. Position of the tetrahedral void. So everyone has understood everything? Then the IQ is very good then. Everyone understood everything, or what? Do you have any questions, or did you understand or no? Yes or no?
No.
Oh no. Okay, fine, good. So that's the honesty I expect. Correct. So so what did you not understand? You know how to draw FCC, right? FCC thing you know how to draw.
Yeah.
Okay, very good. So so now see the tetrahedral void is a bit Because the tetrahedral void, the position is, it is 1/4 away from each vertex. I mean, it is 1/4 away from, rather to say the two adjoint, I mean, the two closest vertices. So this, suppose this. So along the body diagonal. So this, if you look at the cursor, you are following the cursor, right? If you look at the cursor A, this is the cursor. This is one position I'm putting the cursor. This is the other position is this, I'm putting the cursor. So this is nothing but what? Body diagonal. This is body diagonal, right? So, so do you know how many body diagonals you can draw in a cube? In a cube, कितने body diagonal draw कर सकते हैं? How many body diagonals can you draw in a cube?
4.
4, right? Correct? 4 body diagonals, right? Confident, right? So four body diagonals, fine. Now, if you're going with 4 body diagonals, what is happening? See, in the 4 body diagonals, you are having this. So I'm telling that this void position should be lying at 1/4. Now, suppose you consider one body diagonal ranging from A to the ulta side, opposite side. Opposite side I have not labeled it. No, that is the biggest problem. That's why people are finding it difficult. So, okay, but sorry for that. So if you are having A, position A, you are having the other position which is exactly opposite to this. You look at the cursor, right? You are able to follow the cursor, right? You are able to look at the cursor?
Yes.
So now can you
Yes.
draw, now if you draw a line, if you draw a straight line or a body diagonal from point A to the other, to the other atom that is there in the cursor. Okay. So that is a body diagonal, right? That is one body diagonal. वो एक body diagonal होगा, correct?
हाँ.
Right. So now along that body diagonal, I am saying that there are, so how many 1/4 positions are there in that body diagonal? कितना 1/4 position होगा उस body diagonal में, बताओ?
1.
1, is it 1 or think थोड़ा सोच के बोलो. 1 होगा, will it be 1? मैंने एक body diagonal draw किया है, 0 पे है, 1 पे है, और फिर बीच में मैं बोल रहा हूँ 1/4 is the translational distance, correct? वो 1/4 मैं इसलिए कह रहा हूँ 1 from each vertex. So how many 1/4 can you have in 1? 1/4 कितना होता है? 4 होते हैं, right? अब मैं 4 I cannot consider 4 because 0 and 1 I cannot consider. 0 and 1 I cannot consider because 0 and 1 already there atom is sitting. I cannot consider that. बाकी कितना होगा? बाकी
4.
2, sir.
4 होगा? Is it 4 or is it 3? 1/4.
2, sir.
2. Is it 2 or is it 3? That's what I'm asking. See, I want to clear every doubt. Is it
2, sir. 2.
2. Why 2? Why not 3?
You have 2 atoms at the end, so remaining 2
Yeah.
are
Correct.
at the middle, so those
Yes.
2 should be
That's
available only.
what I'm saying. That's what. Yeah, right. You're right. this is the simplest way of understanding. So, तो क्या होगा? 1/4 में एक atom जाएगा. हाँ, मैं कह रहा हूँ कि see, now one can argue with me. You can argue with me that if you have an atom at the body diagonal, ये जो body diagonal मैंने draw किया है, उस body diagonal के center में there can be an atom. There can be, right? Because 1/4 के बाद half आता है. Because 1/4 मैं translational distance दे रहा हूँ. Similarly, I can go 1/4 from there. So there are actually 3, right? But now how am I coming to 2? How am I coming to 2? Why am I saying 2, not 3? Because is the reason is if you read the sentence carefully, it is 1/4 away from each vertex of the cube. So if an atom is exactly at half, it is not 1/4 from each vertex, isn't it? Along the body diagonal, then it will be half from each vertex. Then it will be wrong. In that case, half, मतलब 0 के बाद 1/4, that is acceptable because from one vertex it is 1/4. The other, जो second वाला आता है, जो half होता है, that is not possible because it is 1/2. I mean 1/2 from 1. The 1 by like suppose I'll show you by cursor. If an atom is here, it will be 1/2 from A. Similarly, it will be 1/2 from the opposite end. That is not possible. An atom, if it is T, so this is 1/4, correct. उसके बाद एक jump मारेगा, वो बीच में आएगा, वो बीच में it is 1/2. This other one is also 1/2. That is also not correct. I mean, because that is not correct because it is 1/4 away from each vertex. It's not 1/4 away from each vertex, right? Similarly, when an atom is sitting here, an atom jumps from here to here, then it is what? Then it is actually at this position. So this is actually 1/4 from here, 1/4 from the opposite end, 1/4 from the opposite end. So if it is 1/4 from this end, 1/4 from this end, ऐसा करके कितना हम लोग बना सकते हैं? Total हमारे पास one body diagonal you can have 2, isn't it? 2 positions, 1/4, 3/4. और 3/4 मतलब दूसरे के रेस्पेक्ट में, उल्टा चीज के रेस्पेक्ट में क्या आएगा? 1/4. Similarly, you only told me that you have 4 body diagonals. तो कितना बनेगा? 4 into 2 कितना होगा? 8 words per unit cell. Simple way to understand. Did you understand this?
Yes.
Even if you
Thank you.
please ask.
नहीं समझ आ गया.
That's okay. तो और कोई है जो भी you want to ask something? Because इसके बाद थोड़ा सा डिफिकल्ट एक साइड में दिखाने वाला हूँ, उसके बाद थोड़ा सा वो maybe it takes time to understand. Okay, if you have doubts, you can post in the Google Classroom, but because you have to take only 1 hour class, already is 1 hour, just give me 5 minutes to explain, 5 to 6 minutes to explain the other slide, then I can, then you are free. And okay, so उसके बाद तो, so the main thing is, first I was talking of the position, isn't it? The position of the tetrahedral void. Now, if you talk of the position, then definitely the other question is, what is the size of the void, isn't it? So position हमें पता है, but size पता नहीं है, तो ठीक नहीं है, मतलब जब तो कुछ पता नहीं है actually. So say यहाँ पे भी same convention use करते हैं. Let's do that same thing. You have the gray atom. Here actually there's no atom is gray actually, but what to do? I mean, to use the same color. So let's use the black color atom. यहाँ पे वो black color atom होगा. In place of the gray, it is a black color atom. So with the radius of equal to r, radius of the atom. X is nothing but what? Radius of the largest atom, same thing, which can be fitted within the void, because you have to visualize something. Otherwise, you can't calculate. A is nothing but lattice parameter. E is the edge length of the tetrahedron. Now, this is this might be complicated, because I can show you this. Suppose you have a tetrahedron like this, na? This is a tetrahedron, ना? Tetrahedron मतलब क्या होता है कि total चार sides होंगे और उसमें आपके मतलब not such size. I think it is how much? Yeah. So it's a tetrahedron, means it will be having 3 sides. I'm sorry for that. Yeah. So tetrahedron, it will be having 3 yeah. So 3 sides. So it will be having three sides, and you will be having around the four atoms, right? You will be surrounding it by the 4 atoms, right? 1, 2, 3, 4. So each side of the tetrahedron will be what? E. CD is equal to E. AB is equal to E. BC is equal to E. So same thing. If you are having this, because this is a regular tetrahedron, right? This is a regular tetrahedron. BC, here to hota hai BC. This is BC. BC is equal to E. AC, this AC. This is looking as a hypotenuse. This is not hypotenuse, because if you look into the structure, it is not a hypotenuse. This is not a this is not an obtuse angle or right angle triangle. This is this is an equilateral triangle. So this is AC is E. Similarly, AB is also E, because this is a regular tetrahedron. So we can use this. E is the edge length of the tetrahedron. All the sides are equal. All the sides are equal in the tetrahedron. Now, simple thing is, so this is E. AC is equal to E. E square is equal to what? So this is what? E by 2. क्योंकि एक median तो पता होगा. You people know what is median, right? So AM is nothing but median to BC, right? It is 90 degree, and it is this angle. AMC is 90 degrees. Similarly, AMB is also 90 degrees, and this BM is equal to MC. So what is that? So it's half, right? It's half of the total length. So E square, this is E square, is equal to Pythagoras theorem lagao, because this is 90 degree. So E square is equal to, because we actually want to know about what is the T. T I will come later, but let's calculate this first. E square is equal to E square by 4, CM square, right? This is CM square. CM square is equal to E square by 4 plus AM square. AM square is nothing but it is the median length, isn't it? AM is the median length. Now, if you have the median length is AM, this is CM, this is AC. So you कर सकते हैं. तो उसके बाद क्या होगा? AM is equal to nothing but root 3 by 2E. Correct? Till now, till this, people have doubt. You have a doubt? जल्दी बोलो अभी. उसके बाद तो time
नहीं.
Doubt नहीं है. Okay. So fine. So what will be the AO then? I talked of median. So AO will be what? 2 by 3 AM, because this 2 by 3 of the total length AM. तो AM total अगर length हुआ, AO is nothing 2 by 3. This is basically what? E by root 3, isn't it? It's 2 by 3 of this root 3 by 2E. इसको formula substitute करो, so it will be E by root 3, isn't it? उसके बाद what you can do is you have to find out the other position. I don't know why this cursor is not working or what. We went out somewhere else. Just a second. I mean, are you able to see the screen, guys?
Yes, sir, it's visible.
Yeah,
Yes, sir.
it's visible, no? But are you able to see the change in the screen? I mean, that's what I'm not able to see now. I mean, I don't know. It's got stuck somewhere. Okay, fine. You can do one thing. Okay. It's hard. I mean, if I am not able to show you this to you, then it might be a bit hard for you to understand. I don't know. But let's do one thing. Just guys, can you bear with me for say about 2 minutes? I mean, just this screen is not. Screen has stopped responding or what? I don't know.
Yes, yes.
Just please wait for 2 minutes. Yeah, and again I will start sharing.
Okay, sir.
It got.
Okay, sir.
Just wait. Just 1 minute. Problematic. So I don't know what is happening. Yeah, I can show you in this mode only. And now can you see the entire thing? I'm not showing it in the slideshow. Slideshow might be a problematic. So I will show you. Can you see the entire thing written in the slide? All these the other things also?
Yes, sir.
Okay, now
Yes, sir. Everything is visible.
okay. So I will explain this part by part. So fine. So E by root 3. Yahan tak to it was done. I was explaining till this E by root 3. Now what is the case? Now we are not interested in only this thing now, because we want to know what is the size of the atom which can be placed at T. Size of the largest atom, or rather the radius of the largest atom which can be placed at the position T. So what to do? Kya karna chahiye? So what we do is, you just take this thing, you just take a tetrahedron. That's what I told you. See, octahedral word in FCC is the simplest thing to imagine. You go to tetrahedron, it is a bit hard to imagine, but I mean, I'm trying to explain it in the simplest way. So, kya you have a ABC. ABC, ye wala hai. ABC is this. ABC is the bottommost equilateral triangle, isn't it? The bottommost equilateral triangle. Uske upar kya hai? D. So this is the D. So this is D. This same thing. Point D. These are all the atoms. All these atoms are here. A, D, C, B, and so these are the four atoms are here. But what we are having is at T, we are having a certain a certain void. What is the size of the void, right? So O, we already know what is this length, AO, right? AO is equal to what? E by root 3, correct? AO pata hai. Now this is again actually what? Now if you draw, you have to do some projection actually. So projection geometry is from D to what is the projection of D to AM? It is at O, right? And this this actually is going to intersect this at 90 degree, isn't it? It 90 degree pe wo intersect karega. उसके बाद क्या होगा कि when it is having this, so I need to find out the length dt चाहिए मुझे, because see, I have to come back to some position. I have to come back to a part of the calculation which is easily able to tell me what is see, because I know the atomic radius of the atom placed at point D. I need to know what is the atomic radius of the atom which can be placed at point T. But okay, otherwise, see, for that, first of all, I need to know this length dt चाहिए हमें. So for that, what do I do? So DO square plus AO square is equal to AD square, correct? Yeah, हो सकता है. This is understandable, right? This you can understand. Can you? Yes or no?
Yes, sir.
Okay.
Yes, sir.
Okay. So if it is AD square, तो क्या होगा? AD square is equal to DO square plus AO square. So E square. So what is E square? So AD is the length E, the A is length of the tetrahedron. E square is equal to what? So AO square. So AO is what? E by root 3. So is AO square. E square by 3 plus DO square. So DO will be equal to what? E root 2 by root 3, isn't it? So if you simplify this, now, so what is dt? So and this is a property of a tetrahedron. dt is nothing but you can, I mean, I'm not going that much into mathematics, but it actually comes like this. But dt is equal to 3 by 4 of do. Okay, so this is the geometry. So dt is equal to 3 by 4 of the do. So dt will be what? Root 6 by 4, right?
Yes, sir.
So if it is dt is equal to root 6 by 4e, so e kya hoga? Now you think of the two, everything you forget. Now dt ko leke socho. So dt mein kya hoga? You have an atom at point D, that is radius is equal to r, isn't it? dt mein d mein ek atom hai jiska radius hai r. So r. Similarly, you also have another atom. I mean, this is the, suppose this, you have to think of it as an imaginary atom, because there is no atom, right? This is a void. You have to now think of it as an imaginary atom where radius is equal to small x, isn't it? So dt is equal to ये atom का जो radius है x plus ये atom का जो radius है, this is r. So the radius of this atom plus the radius of this atom. So that's r plus x. So it's equal to what? So dt, you already know the value. Root 6 by 4e is, you already know the value. So that is equal to r plus x. So now, e or r, what is the relationship? Now you have to look at d में एक atom है, that is the radius of equal to r. point A also has another atom where their radius is equal to r, right? So like here, here there is one atom radius r, here there is another atom radius r, but I am not going to consider this center distance, because see, when the atoms are packed, there is nothing line in, in an atomic bond. There is no line. Rather, an atom is going to touch directly the other atom. No, that's why the concept of coordination number, etc., all these things evolve. So for that, what you are essentially going to do is that E is equal to 2r. Now, so dt is equal to root 6 by 4e. So root 6 by 4 into 2r, root 6 by 2r. So root 6 by 2r is equal to r plus x. So x by r is equal to what? Root 6 by 2 minus 1 is 0.225. So this is the radius. So this is the radius of the largest. I mean, with respect to the r is the atomic radius. So this is the radius of the largest atom, or the or rather the atom. I can change it. So the radius of the largest atom, which may be fitted within the void, which may be fitted in the void. I mean, the void at point E. Similarly, all the other positions also you will have the same void with the radius of equal to 0.225 r, or 0.225 with respect to the atomic radius r. So that is something, I mean, that is the radius, or that is the size of the tetrahedral void. Did you understand this? Yes or no? I was audible, no?
समझ आया.
You understood, or you have a doubt? Please ask.
No, sir, we have understood.
You completely? Okay. So if you have,
Yes, sir.
Yes, sir.
very good. So if you have understood it, then can I give you like, you see, this is done. I mean, your today's class will be done, but you just have. I mean, I should not call it a homework. I mean, I was using it for a different thing. Yeah, I can tell that this is a brain teaser. There is no homework. This is not a regular classroom, so I cannot give you a homework. So rather, I can say, now that you know about octahedral and tetrahedral voids in FCC, right? You know about both these voids. Can you do the same exercise for BCC? I mean, it's very hard. I know. You can try it at home. If not, you can definitely, you see, you post it. Okay, you don't know, then I mean, first you give a try. Okay, first you give a try. You first give a try. What I will do, I will make a separate folder. Okay, I will make a separate folder in this Google Classroom. Okay, okay. I will give the link access to all of you. You just free time, you can just draw the structure and try to think about the tetrahedral voids. I mean, how can you visualize a tetrahedral void and and draw it, and then you can upload it better. So once you upload it, then I will have a look into that, and then we will discuss likewise. Is it a good idea, or are you guys interested to do that in the BCC? Because FCC, I didn't want to talk about today because already it is 1 hour 30 minutes. Then it would be 2 hours or something. That's what tetrahedral voids. Once you know this concept, right? Octahedral void, tetrahedral void. So can you do it for the BCC? Once you are able to do it yourself, you can do a lot of things. I will tell you, I will also upload some other things regarding why should we at all first understand voids? Why do we need to learn voids at all? Because you cannot be learning out of thin air. Why do you need to learn it? So can you do it? Can you do this assignment kind of thing? I mean, not assignment. I cannot do this. There's no.
Sir, what we need to do actually?
Do the same thing. I mean, calculate the size and position of octahedral and tetrahedral void in BCC. Do the same exercise. Na? Same exercise that we have done. I mean, we have discussed today. Na? Can you do it for BCC? Visualize. First visualize. See, there is nothing wrong. If you are not able to do it, no problem. But give a try. First. If you're not able to do it, then I'm of course there to talk about that. I'll talk about it. But definitely, first to give a try. Is it okay for you guys? You got the homework, right? Or assignment or something, kind of what I should say. Have you got this idea? Like, to calculate the size and the position of octahedral and tetrahedral voids in BCC. You know about FCC, right? FCC, everything is given. I've given it. Can you do it for BCC?
Okay, sir.
Okay.
So another thing to ask, for the class timings, should this timing would be there or another time would be
See,
there?
I have the problem is we can give another timing, but I have no problem with this class timing. I mean, if you guys have problem, then say, because 5 to 6 is actually the best time for me, because you see, even you people will have classes. No, even you people will have classes in the afternoon. No, in this this thing on Friday, because we are doing it not on Saturday. We are also doing it on Friday, Saturday, Sunday. But tomorrow, Soumya will take it. Yeah, yesterday Gaurav took it. So today I took it. So that's what. No, I think if you are having this timing, I think we should stick to this timing. But I want to know about your opinion. But guys, please don't make it in the morning. Morning session will be very bad, because morning session problem is I might be busy because I have to go to lab. No, I have to have meetings also. And then I think best timing is this one only. No, let's keep it 5 to 6. You anyways you are at home. You don't have classes also. No, 5 to 6. Do you have classes, guys? Any extra class or something? Anything you have?
No, we don't have any extra
Then it
classes.
is okay. Then it is okay, no? 5 to 6 is fine, but okay, we can adjust. So everywhere. See, it's not a hard and fast timing. We can definitely, based on some occasion is there, something is there. We'll definitely adjust because even even we need to enjoy also. But of course, but no, but sometimes also I have to do my job also. Will it be okay? 5 to 6, I think is fine. But okay, so let me know. Okay, let me know what are your opinions. I think what you can do, you can have my suggestion is maximum you can do from 4 to 6, maximum from 4 to 6, like 4 to 5 or 5 to 6. We can give a choice, because see, for till 4, definitely I'm sure that you are going to have classes. Na? In the morning, so starting from 8, you will have classes till 4 or something. Second year, definitely you have a lot of class pressure. No, so I'm not sure. That's what I was thinking about 5, because 5 every class is over. No? Let me know. Okay. So guys, fine. So today we'll stop the class here. Okay. So any doubts you have, please ask me. I'll stop this.
Sir, sir,
Yeah.
sir, about the questions you gave, sir, we will definitely give it a try. But if
Yeah,
we are not able to do that,
yeah, we'll
sir,
we'll
please
discuss.
you help us in the next.
Yes, no problem. Definitely. See, that's why we are here. Otherwise, see, we are not like the professors. No? We are not the professors. Like we are not going to judge you anyway. I'm not judging you, because I was myself like you only. No, 2-3 years back, I was myself like you only. You would know this, so nothing like that. So don't worry.
Sir, and about the class timing, sir, we will definitely, sir, we will discuss in the group of college and class group, and we will definitely let you know, sir.
Okay, so the thing is, my suggestion to all you guys is, see, in the morning time, if you do, it might be a problem. See, Saturday, Sunday, there is no problem. Saturday, Sunday, I think we can do it. The problem is Friday. Now, 3 people are doing. See, now today, see, I am doing from in the morning. Suppose 9 to 10. Suppose one situation. On the Saturday, there is another guy who's doing from 5 to 6. But then that guy might demand that why cannot he do it from 9 to 10? But the problem is, on the Friday you might have a class, right? On Friday you might have a class that time, and then you might be in trouble. The morning I cannot take up this session. No, so this is just an interactive session, and for this interactive session, some free time is really good, isn't it? But okay, you can discuss. Amongst yourselves. Okay. Thank you, guys. Today, thank you guys for.
Okay.
I was.
Thank you.
Yeah, very good.
Sir, better if you upload the today recording on YouTube.
I will upload. Don't worry, I will upload. I have a folder. I have a folder in this Google Classroom. I will upload this so that you can also have a look into it. Whatever, say again, you go through it repeatedly. You will definitely have doubts. I'm pretty sure of that. You will have doubts. Then definitely you should raise this things up in the Google Classroom. Otherwise, the learning will not be interactive. So that's what. So definitely. Okay, and guys, one more suggestion I have. Whatever, say, you guys are free to talk. There is no problem. Like whenever I don't need to ask you yes or no all the time. Whatever I talk, you can interrupt me and then just tell me, okay, Manak, I can't understand this thing. That's fine. I will definitely address you. It's not like I'm not a professor, right? So I cannot. I'm not at all like you have to listen to me. It's not like this. I have to talk, but you should also tell me where you cannot understand. Suppose you don't understand, you just interrupt me and just say, Manak, I'm sorry, I cannot understand. That's it. No problem. I will explain this. I will explain this times 3-4 times. How many times you need to till you get an understanding. That's important in a class, right? So that's the only thing. Keep this in mind. But that's it. Otherwise, the class was very interactive. Thank you. Have a nice weekend. Okay.
Thank you. Thank you.
Yeah. Thank you, brothers. Okay.
Thank you, sir.
Okay.
Thank you.
Thank you.